recording. See the little red dot down here, the little So we might as well, let's talk about quadratics. Quadratics. What's a quadratic? Anybody? A what? Okay, there is a quadratic formula, but that's not what a quadratic is. What's a quadratic? What kind of equation? Tell me what you know. Anybody? Did y'all learn about quadratics in Algebra 1? A little bit. Tell me another type of equation that you know. A linear equation. An exponential equation. These are all different types of equations that give us different types of graphs, right? Linear, just a line. Exponential, and we'll do a whole unit on exponentials, look something like this. What does the graph of a quadratic look like? A U. What's it called? Do you know? A parabola. A parabola. A quadratic. Y'all don't be scared to answer, even if you don't know the right answer. It's okay. We're all in this together. When I graph a quadratic, it is what I call a parabola. And so Kate says it looks like a U, and he's exactly right. And it could open up or it could open down. So when I graph a quadratic, so graphically I know what it looks like. But algebraically, in terms of an equation, what does a quadratic equation look like? What's special about a quadratic equation? It's y equals. What's different from a linear equation and a quadratic equation? How do you tell the difference? What's a linear equation look like? That's exactly right. Mx plus b, right? Y equals mx plus b. So that m and that b could be anything I wanted it to be, right? The quadratic, I'm going to just go ahead and, I don't feel like I'm prodding y'all in the right direction here. The quadratic has an exponent of 2 on the x. Y'all remember this now? No, if you don't, it's okay. It's all right. So there's no, in a linear equation, x just stands alone. It can have a coefficient in front, a number multiplied, but no exponent. But in a quadratic equation, I have an exponent of 2 on the x. And so a general form of a quadratic looks like this. Ax squared plus bx plus c. A, b, and c are all called coefficients. They might be there, they might, well, actually A's got to be there, but B and C may be there, they may not. The key to the quadratic, though, is this power of 2 on the x. Is everybody with me? Okay, before I go any further, tell me, quadratic or no? No. Why? No exponent on the x, right? That is what kind of equation? Linear. Yes. Why? The exponent is 2. Yes, that is quadratic. Quadratic or no? Yes, even though it's written in a different order, that's okay. So when we're in standard form, we're writing from the biggest exponent down, but it doesn't have to be in standard form to still be a quadratic. So because of this exponent of 2, it's yes. And I should clarify a little bit, not just an exponent of 2, but the biggest exponent in the equation is 2. So if I had something like that is no longer a quadratic because the biggest exponent here is 3. Does that make sense? So looking for the biggest exponent being 2 to be a quadratic. Everybody okay? Can you identify a quadratic equation? Yes, no, maybe so. Yes. All right, let's go back to the ones that we looked at being quadratic equations. And remembering what I told you, that quadratic equations can always be written as ax squared plus bx plus c. And this is standard form. If I go too fast, y'all just slow down. Looking at this first equation, what is A? What's the A in the equation though? 5. I'm sorry, that's what you said. Sometimes it takes just a minute to register with me. What's B? There is no B. So what do you think B is? 0. So if I just had an X there in the middle, it would be 1. But if it's missing altogether, it's 0 because I can always add 0. How about C?
3.
Close. Negative 3. Y'all okay with that? How about the next one? This one's a little tricky. What's A? Negative 1. Good job. Why is it negative and not positive? It's subtracted, right? But A is always hooked to the x squared term. Always, always, always. What is B? How about C? Look at y'all. Yay, nay? We okay? Sure. You also have to speak up and tell me if you're the slightest bit confused because I don't mind doing another example, but I don't want to keep going if everybody's good. Y'all okay? Identify quadratic. Identify A, B, and C. There's coefficients. Okay, let's talk about the parts of the quadratic. And I'm doing all this so that we can get to the graphing part of it. Let me give you a little background. Make sure you remember. When I'm in standard form, and I always want to get back to standard form when I can. We said this are called coefficients because coefficients are just numbers that precede a variable, okay? And if they're missing, then they're 1. But if the whole term is not there, then they're 0, right? And these are terms. This is 1, 2, 3 terms. Am I using too much math lingo for you to? C is not a coefficient. What is C? It's a number. What kind of number? What kind of a number is a number without a variable? What do we call that in math? It actually starts with a C also. There you go, a constant. It's a constant. It's a constant because no matter what value I plug in for the variable, it stays the same, right? It's a constant. It's always the same. It's constant. All right. In a quadratic equation, C has another very special property. That special property is that it also serves as the y-intercept of my parabola. What's a y-intercept? Crosses the y-axis, right? Intercept means crosses. So if it's the y-intercept, it crosses the y-axis. And this makes sense because how do you find a y-intercept? How about algebraically, how do you do it? Close. You're close. If I gave you what are the coordinates of this point right here? What are the coordinates of this point? What are the coordinates of this point? What always happens at a y-intercept? What's 0? The x is always 0. So to find a y-intercept, I can plug a 0 in for the x. If you put a 0 here and a 0 here, what happens? And it leaves you with the constant. That's why the constant is the y-intercept. Are y'all okay? Some of y'all are, oh gosh, what have I gotten into? It's okay. We're going to pull it all together and it'll all make sense. Okay, let's talk about graphing a minute because we're going to pull this back to the graphing. We said when we graph a quadratic, it looks like what? What's the word? A parabola, right? And it can be up and it can be down. And not only can it be up or down, But it could be super skinny, really wide, either way, right? All of these are different parabolas, and they're all quadratic. So as we graph them, I'm going to teach you how to look at the equation itself and pick out some pertinent information that will help us in graphing. So let's look at an equation. And let's see what we can tell. Actually, let me tell you first, and then we'll look at the equation. We already know one thing. What's the one thing we already know? Graphically, the constant is the y-intercept, or the c. That's right. So this is the y-intercept. Now, A tells me a lot of things about my graph. Okay, a whole lot of things. It tells me two different things that are very, very, very important. First of all, A tells me whether my graph is going to open up or it's going to open down. Okay, if it opens up, A will be positive. So I'm going to be a parabola opening up. But if A is negative, what do you think happens to the graph? It goes down. Now here's the other thing A tells me. Do y'all remember learning about graphic transformations? If you multiply by a number, if it's a shrink or a stretch, does it this way or this way? Do y'all remember doing that? So A is my, if you don't, it's okay. A is my stretch or shrink factor here. So what it's going to do is it's going to tell me if my parabola is going to be wide or if it's going to be skinny. Okay. The bigger A gets, this is where it gets a little confusing. The bigger that A gets, but I'm talking about absolute value of A here because I'm not looking at positive or negative. That just tells me up or down. The bigger A gets, as A gets bigger, my graph gets skinnier. So it's kind of the opposite of what you think it would do. Yeah. So if I had a really big A out front, like if I had a 250 out front, that's going to be a really, really thin graph. But as the absolute value of A gets smaller, now I'm saying getting smaller, but I'm not talking about negative numbers. So what exactly am I talking about? Y'all can do this. How do you get smaller but not go negative? What am I looking for? What kind of values? What kind of values get smaller but never go negative? Fractions. That's exactly right. If I keep cutting a number in half, half of one is a half. What's half of a half? A fourth. Half of a fourth. An eighth. Half of. You see what I'm saying? I'm getting smaller, but I'm never going to go negative. So that's a good job. So as the absolute value of A gets smaller, the graph actually gets wider. I know this is a lot today. I'm sorry. Just because it's the very first one. All right. So before I throw any more on with that, let's stop a minute and let's look at a couple examples. Y'all excited about that? Okay. Thank you. I appreciate your enthusiasm. Am I going too fast? Too slow? This is good. What is A? 1/2. What's B? Ooh, good job. What's C? Good job. Y-intercept? Look at y'all go. Am I up or down? Why? Because it's positive. Up because A is positive. All right, here's the tricky one. Am I skinny or wide? Wide. It's a smaller number. It's a fraction less than one. One is kind of your parent. That's what you're going to go off of. As I get bigger than one, I'm going to say I get skinnier, and as I get smaller than one. So one's really one's what we call the parent graph. Have y'all learned about parent graphs? So one is the what's the word I'm looking for? Oh, standard. That's the word I'm looking for. One is the standard. That's what I'm going off of. The bigger it gets from one, or the smaller it gets from one. Thank you. So this one would be y. Good job, y'all. Got it for a second. What's A? Oh, let's got this. What's B? What's C? Okay. You can list out A, B, and C. It makes life so much easier as you start to analyze some things. Y-intercept. Up or down? Nice. Skinny or wide? Ooh, let's debate. Why? It's a fraction, but it's 5 over 2, which is 2.5, so that's bigger than 1. So what is it? Is the negative impacting my skinny or wide at all? No. What is the negative doing? Up or down? That's it. That's the only thing the negative is doing. Are y'all okay? Are you sure? Okay, let's talk about some properties of the graph, and then we're going to put all this together and we're going to actually graph it. Yeah. Wait. A. Then 1. Right. It does the opposite of what you would think it would do. Yes. You told me that a quadratic. If y'all need a break in between, let me know. Like if you need to go take a lap or something, sometimes we'll take a frame break because things start having smoke come out of your ears. Okay. Parabola, yes? Agreed? Yes. This is what a quadratic looks like when I graph it. Tell me some things you know about a parabola. Or do you know anything about a parabola? You know what? You know what we just learned? Okay. What about the graph? What do you know about that? Anything? It's shaped like a U. So tell me some things about a shape like a U. There, it's symmetrical. That's a good point. Absolutely. So a parabola is symmetric, and I drew this line of symmetry, and you'll see why I drew it. So this means that from this line of symmetry, these points are equidistant to get to that line of symmetry, right? That's what symmetrical means, right? That's probably one of the very few things that you'll use from geometry that you've learned in here. What else do you know? Very good. It possibly crosses over X 2 times, and we're going to really focus on that a little later in the chapter because that's a very good point. It could have 2 X intercepts, but we'll always only have 1 Y intercept. That's an excellent point. I don't know that I've ever had anybody get that the very first time. Good job. See how it could cross twice? Now, depending on where it's shifted and where it's moved, maybe it only crosses once, or maybe it never crosses. But this graph, as opposed to the linear graph that you are used to, could potentially have 2 x-intercepts instead of just 1. So that's a great point. Also notice that it bottoms out here, right? It has a very lowest point that it never, ever, ever goes below. Do you know what that point is called? A B. Vertex. Somebody said it. A vertex. It's called the vertex. And what happens is, as I'm looking at this parabola, I'm going from left to right, same way you read a book, left to right. Some of us struggle with that reading a book thing, right? But left to right, the same way you'd read a sentence, not a book, a sentence. Left to right. I'm going down, right? Down, 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 down. This is the point where I stop going down and I start going up. So sometimes we might call this a turning point because it turns, the graph turns there. But we'll refer to it here as a vertex. All right, so what we're going to do to graph, this is a very, very important point. Okay, very, very, very important. The vertex and the intercepts are very important points. I'm going to focus the graph on finding this vertex and then finding 2 points here to kind of connect. And that's how I'm going to work on graphing. Everybody okay? All right, y'all ready to jump into it, or do you need a break in between? Logan's ready. He said do it. Everybody else ready? Yes. This is an example. So what I'm going to do, I try to do this anytime I can. I'm going to run you some steps along with an example. So you kind of have in your notes someplace where it says how to do it and then an example that does it while I'm showing you with steps. Everything doesn't lend itself to steps, but some stuff does. Let's do how to, let me organize it a little better for you. How to graph in standard. Remember, standard is x squared plus bx plus c in standard form. We'll do steps on this side, and on this side I'll run an example. This is my typical little step chart. Am I feeling overwhelmed? Is everybody okay? You like this? I'm so glad. I'll give you a second to copy it down so you're not frantically writing while I'm talking and missing what I'm saying. You ready? Yeah. Like when you're plugging in or anything, you'd plug in the same value for both x's. You're just going to square one of them and not the other. Yeah. Any other questions before we jump in? Before we even start, my example that's on the right, is it going to be up or down? Up or down? I hear both. Down, why? Because it's negative in front. Exactly. Y-intercept? 7. Skinny or wide? Trick question. Or average? Normal or average? This is standard. There you go. All right. So we know a lot about it before we even graph it, right? We know it's going to go down, it's going to cross the y-axis at 7, and it's going to be an average width. So I'm good to go. All right, so the very first thing I'm going to do, I told you there was a really important part of the parabola. What was that called? The vertex. This is going to be the only thing that you really have to memorize something for to figure out how to do it. First thing we're going to do is we're going to find the vertex. And I haven't told you how to find the vertex because it's not quite as easy as just finding the y-intercept or anything else, because there's a little bit of work we have to do with it. Thank you. Sorry, y'all. We got People visiting from the Citadel. Well, they want to come in my third block class. I told them they should come in and talk to y'all, but they didn't want to. I did. They said y'all aren't old enough yet. All right. To find the vertex, here's what I'm going to do. I'm going to plug in this little formula. Now, remember the vertex is a point, right? I'm giving you this formula, and by the way, this is opposite B, even though it looks like a negative sign in front, right? And that is a negative sign, but I like to say opposite B, because what if B starts out negative? Then it's going to be positive. That's exactly right. So opposite B over 2A, all right? And that's going to give me the X part of my vertex. Now, let me digress for just a minute over here, and let me show you. If this is my vertex, remember we talked about that axis of symmetry, and that line of symmetry. Sometimes we call it an axis. It goes straight through the vertex. Okay, it always goes through the vertex. So it's a line. Do we agree it's a line? How do you write the equation of a vertical line? Say again? I didn't hear what y'all said. Y equals X is a diagonal line. It's X equals a value. So this, whatever this value is, if you think about whenever you're graphing, this line would be X equals 2. Vertical lines are in the form X equals a number, right? I'm getting to a point with this. If the axis of symmetry goes through the vertex, then the axis of symmetry is going to be the X part of the vertex, right? Whatever this is. Okay, just say right because it's right. That'll make sense in a minute. Okay. All right, so to find the axis of symmetry, also known as the X portion of the vertex, I'm going to plug in this little equation. All right, I got opposite B over 2A. So over here on the right side, for my first step, I'm going to say my vertex is, first thing I'm going to do is opposite B over 2A. Now here, I'm probably going to come here and write A, B, and C, just so I keep my variables straight here. What is A in this equation? What is B? What is C? So if I need opposite B, what goes in the top? Opposite B. You're jumping ahead. 2 over 2 times, what is A? Negative 1. Are y'all following me? That's a no. All right. This is my equation I'm using, right? Opposite B. So B is negative 2. So opposite B is 2. And then 2 times A in the bottom. 2 times A is negative 1. Are y'all with me? 2 over negative 2 is, okay, so now I know I have a y-intercept at 7. I'm opening down, and my vertex, the x part of my vertex, which is also my what? Starts with an A. Axis of symmetry is at negative 1. So far, that's what I know. Everybody good? Where on this axis of symmetry, I don't know yet, but I do know the vertex is on that axis of symmetry. Which brings me to the next part. I've only found half the vertex. How do I find the other half? Y'all can do this. Think about it for just a second. A vertex has 2 parts. It has an X and a Y, right? If you have X, because I do, I have X, yes. Yes, you plug it in. You have to plug it in. If I have X and I need Y, well, this equation says, Y is negative X squared minus 2X plus 7. So if I know X, I could easily find Y, right? So I'm going to come over here and say plug in to find Y. Sometimes I'll make you come to this conclusion on your own, and then I'll just tell you what to do, because I feel like it helps your understanding a little bit to understand why we do what we do. But Regardless, I go back to my original equation. This is kind of, you probably did it in like a T-chart form back in like 7th or 8th grade. But you're just plugging in this -1 value for every x in this equation. Okay, so I've got this negative out front, and be very careful because that negative sits out front of that x. So I got -1 squared minus 2, -1, plus 7. All I did was take out every x and plug a -1 in place of it. Does everybody see that? Okay. Now let's simplify it. This is the hardest form to graph in as well, y'all, so I'm sorry. It's a loaded lesson for the first day. Order of operations. Exponents come first. This is one like we did on that little Kahoot yesterday, right? Where the negative comes. Do the exponent first. -1 squared is 1, but then I have to do the negative of it. So this becomes -1. Everybody see that? Squared, it becomes positive. Then I do the negative. Minus -2 plus 7. What do you get? 8. I didn't believe you at first. I had to do it. What is my vertex? All that step 1. Plot it. So I should say plot. Very good. Step 2. Here's where your steps start to, they could go different ways. I need find an easy point. Now, remember these properties we talked about this parabola, how I reflected over that axis of symmetry. So I really just need to find one more point, and then I can use what I know from geometry. Are y'all sure you don't need a break? Because y'all are starting to like fizzle out on me. Okay, Logan's okay, but what about everybody else? Y'all need a sip of water or walk around a lap or anything? Y'all are okay. Okay. Y'all look awful. I know. I think I'm losing my voice. Okay. My advice to you on an easy point. Use the y-intercept. Notice I said if you can. Sometimes you can't. And I'll do an example next where you can't use the y-intercept. If the vertex is your y-intercept, you can't use the y-intercept. If your y-intercept is 150, you don't want to count up 150, right? That wouldn't be a very good easy point to use. So I would use the y-intercept if I could, and I would let that be my easy point. But we'll do one in just a minute where you can't use that. But for this one, what's my y-intercept? Y-intercept.
No.
Okay. The y-intercept is 7. It's that C that's on the end. Can I use that one? Yes, I can use that one. That one's easy to use. I would consider that a very easy point. Now, if you can't use that, I would advise you just to go one away from the vertex. So if the vertex is 4, maybe x equals 4, maybe you go to x equals 3 or x equals 5 and plug it in to find that point. We'll do one like that in just a second. All right. Y-intercept is 7. Plot it. Once you have your easy point, the third step's my favorite. I'm going to coin this phrase. Yep, just plot it. Now, if This one was easy because we used y-intercept. If you can't use y-intercept, it's not nearly as easy. Okay. This is my favorite. Y'all ready? Yes, Miss Vicky, we're ready. Thank you. Thank you. We'll say no. Okay. Reflect and connect. Isn't that a cool step? Reflect and connect. It's the last one. I coined that phrase though. Wait till y'all do your raps and your songs and stuff. I can't wait. All right, I'm going to reflect it. What am I reflecting it over whenever I say reflect? Oh my goodness. The axis of symmetry. That's exactly right. I'm reflecting it over the axis of symmetry. So here, I go over one to get to the axis. Disappointment. And over one more to get here, right? I reflected it, and now I'm going to connect it. Yes? Now don't make it a V. It's not a V. It's never a V. It's a curve. That's right. And all that has finally allowed me I don't always do this for you, but I have some little guided notes here in case you're on. So on one side there are steps here. This is something I used to teach CP algebra 2 a long time ago. And I have a lot of little references to help them, but I find it's helpful no matter what level you're at. So I printed it out for you guys as well. But these are pretty much the same steps. They're just broken down a little bit more. If it helps you, that's wonderful. Some things to consider down at the bottom. We've kind of talked about those things, how A impacts your graph, what C is, and how to find those values. But if you flip over to the back, there's an example there. That's actually the example we just worked through. And work through it so that you'd have it written here and you'd have it in your notes. And we're going to do the second example here together right now and run through the steps and make sure. I know that this took a very long time for us to get through, but remember, I'm teaching you how to do it as we go, so they won't all take this long to actually grasp on your own. All right, y'all still good? You don't need a break before we need another one? Just one more? Oh, okay. You have one, Wyatt? Everybody's got one? I absolutely can, yes. Okay. All right, let's do the example together that's on the bag. It says example 2, and it is y equals 1/2 x squared plus 2x. And you have to draw your own axes in there. I'm so sorry. Not really, but just draw them in there. Before we begin, tell me, is it up or down? Why? It's positive. Skinny, wide, or average? Why? Smaller than 1. That's exactly right. Y-intercept? 0. 0. Ruh-roh. It's going to be 0. That means my y-intercept, well, you don't know that yet. Okay, never mind. All right, that's okay. Y-intercept is 0. All right. What do I do first? Tell me what to do. Okay. A. No. 1/2. What's B? C. What now? First step is to find the vertex. To find the vertex, I need a little teeny equation. What is that little teeny equation? That's exactly right. X equals opposite B over 2A. Well, now that I've listed A, B, and C, that's easy, right? Opposite B, so -2 over 2 times A. I lied. This is still one we can use the y-intercept on. Great, dang. I'll do another one in a second. What's 2 times 1/2? 1. So I have negative 2 over 1. Everybody good? Is that my whole vertex? No. That is only what? The x, which is also the axis of symmetry. Good job. However you want. This is just for you. So now I need to know where on my axis of symmetry I go. So what do? I plug it in. What do I plug in where? Plug the negative 2 into the x to find y. That's exactly right. So 1/2, I put a negative 2 here, squared, plus 2 times, and I put a negative 2 here. Everybody good? Exponents come first. Negative 2 squared is 4. Then multiply by 1/2. 2. 2 times negative 2 is negative 4. So 2 plus negative 4 is, so what are the coordinates of my vertex? Negative 2, negative 2. Could I use my y-intercept here? Yes. I'm not going to, just for sake of example, to show you how to use something if I couldn't use my y-intercept. So let's say I couldn't. Let's pretend like the y-intercept was like 150 something, and I didn't need to use it, and I need an easy point. I'm going to look at my x part of my vertex. What's the x part of my vertex here? Negative 2. What's a number that's really close to negative 2? Negative 1. Let's use negative 1, and let's plug that in to find the other part of the point. So y equals 1/2 negative 1 squared plus 2 is negative 1. Finding another point on the graph. Remember, I need the vertex, and then I need one other point somewhere on there. I didn't use the y-intercept this time, even though I could have, because I wanted to show you what would happen if you didn't. It still works. All right, negative 1 squared is 1. 1/2 of 1, 1/2, minus 2 would give me, that's right, negative 3/2, negative 1.5, negative 1.5, any of those would work. So this point is negative 1, negative 3/2. I looked at where I started with the vertex, and I just came one beside it. Negative 1, negative 1.5 would be here. And now what? What's your last step? Reflect and connect. Over 1 over 1. Did it do everything it was supposed to do? Does it open up? Is it wide? It is wider. Is the y-intercept 0? Actually, yes, if you drew it correctly, it would be. I didn't make you do that. But had you used the y-intercept, it would have worked. Tell me problems, issues, or concerns. What's wrong? Negative 1, negative 1.5. That's correct. It's the x part of the vertex. So then we needed an easy point. And I told you to use the y-intercept if you could, but for this one, I just wanted to show you what would happen if you didn't use the y-intercept, because sometimes you can't. And this one we could have, but Everybody give me a thumb. I can graph a quadratic in standard form. Yeah, so. I don't got it at all. Everybody give me a thumb. Okay. It's kind of, okay. Let's do one more together then. Let's do one of your homeworks together. Hmm? Why? Oh, yes, yes, yes. It may just be because you only do, a lot of teachers will make you do 2 points on either side. I think it's a little overkill with that because we're going to get to where we graph them on our calculator soon. But it's just because you just have that 1 point is fine. What? Yes, to get to that one, but she's asking about it being y. Why? Yes. You just so you count over to the axis. So it took me one to get over there. So you count over one. And that's the nice thing about if you stay just one right beside the vertex is you're always just going one. If you'd use the y-intercept, you'd be here and it would take you 1, 2 to get over. So it'd take you 1, 2 to rotate. All right, look at 1 through 6 because that's all you have for your homework and tell me which looks the hardest and which do you want me to do with you. Versus 5. I will tell you 4, you won't be able to use the y-intercept. That'll be your one that you can't use the y-intercept on. Which one do you 5? Well, 5's got a fraction. It's up to y'all. Which one? 4? Raise your hand for 4. Raise your hand for 5. Okay, 4 it is. And then if we got time, we'll look at 5. Y equals negative 4x squared plus 8. What's A? What's B? What's C? Up or down? Down. Down, down, down. Skinny or wide? Skinny. Y-intercept. Very good. All right. The bigger the absolute value gets, the skinnier it gets. So since that's bigger than 1, it's getting skinnier. All right, let's find the vertex. Opposite B, what is B? Over 2A. Can you have a 0 on top? I don't know, you tell me. There's some place you can't have a 0. Where can you not have a 0? At the bottom. The bottom would make it undefined. The 0 just up top just means that this equals 0. So you can never divide by 0, but you can divide 0 by something, and it just gives you 0. All right, so that gives me not my vertex fully, but my, what's it called? Line of symmetry or axis of symmetry. All right, so axis of symmetry is actually the y-axis on its own. Yep. So where on that axis of symmetry lies my vertex? Well, I need to do what to find that? Plug it in, plug it in. That's right. If I plug in 0 for x, So the coordinates of my vertex here would be 0, 8. 1, 2, 3, 4. Okay, we have a slight problem because I need my easy point and I would really like to be able to use my y-intercept, but I can't. Why can I not use my y-intercept? It's already the vertex. I can't use it for a second point if it's already my first point, right? So I need to choose a point that I'm going to be able to use. What do you suggest? 1. I would say for my easy point, 1 is a great option. It is just right next to the vertex. The further away you get from the vertex, it's going to start getting really big really fast or really small really fast, because think about the way that parabola jumps up. So I'm going to stick close to the vertex. I'm going to let x be 1. And now I'm going to plug in. Negative 4 times 8. What do you get? 4. What are the coordinates of my easy point? 1, 4. Y'all okay there? Yep. So you can really use anything you want, but to make it as easy as possible, look at your vertex part, add 1 to it, and let that be your easy point. What's your last step? Reflect. So 1, 1, and connect. Yay or nay? Yay! Okay, so